So welcome to this latest video on 162 Maths, and in this video we'll be going over a collection of some GCSE Maths past exam questions related to statistics from the foundation syllabus. Now as always, I'll include a copy of the questions that we go through in this video in the description below, which I strongly recommend you have a go at before watching through this video so you go through the answers so you can test your prior knowledge. I'll also include a question breakdown so you can see which question refers to which topic, and also include a contents page to all the videos on my channel which go over each of the topics in statistics in greater detail. Now before we get started, as always, this is not an exclusive sort of work through every single possible question on every single particular topic in statistics on the foundation syllabus. They are just a small collection of different types of exam questions summarized briefly in a set of exam questions. So it's really important that you don't just simply revise off this video and the questions that are dealt in this particular question sheet, simply because although the questions may be a little bit difficult for foundation syllabus, they're not exclusive in terms of everything that's involved. So it's really important that you study each of the topics individually, understand the types of questions, and this is where topic tests or going through a lesson that goes over these particular topics in detail is definitely worth incorporating in your revision. Now, as always, just a little reminder that if you're wanting a copy of the questions that we go over in this particular video, all you need to do is just simply click on the link in the description. I'll also include the contents page, which has links to all of these topics that go over all of these particular topics as lessons, so you can get and improve your depth of knowledge within that particular topic. So let's get started on question 1. So question 1 reads, Kim works at an airport in the UK. She records the number of planes landing between 10 AM and 2 PM each day. The table shows the data for the first 10 days in January, and question 1A says the airport was affected by fog on one of these days. Which day do you think it was? Give reasons for your answer. So here, if it's been affected by fog, that means there's going to be less planes. So we're looking for the day where less planes landed, and that is going to be day 8. So we just need to write day 8, and the reason for that is because it's the lowest number of planes landed on that day. So again, you could go on to explain, well, if it's foggy, you would expect there to be some travel disruptions, which means there'll be less planes because the conditions will be worse. Moving on to question 1B, it says Kim uses the data to predict how many planes will land at the airport in a year. In her method, she uses an estimate for 150 planes in each 4-hour period throughout the day, assuming that the same number of planes land each day. Work out her prediction. Well, if we're looking at 150 planes in 4 hours, then what we need to do is then work out how many land in a day. So we multiply that by 6. And we multiply this number by 6, which is going to give me 900. So that means 900 planes land on a day. And if that's one day, then we need to multiply that number by 365, because there's 365 days in a year. So then 900 times 365 gives me an answer of 328500. So the answer then is 328500. Then moving on to 1C, it says, in fact, few planes land in the winter than in the summer. Fewer planes land at night than during the day. What does this tell you about Kim's prediction? Well, the box that we need to tick is that her prediction could be too low or too high. And the reason for that is because too few in winter make, oh, don't know what's up in there. The prediction too low, and too few at night make the prediction too high. So something along those lines would be absolutely fine. Moving on to question 2, it says here is some information by ticket type about the number of people visiting a cinema 1 week. And we've got adults, students and children. And for 2A it says how many children visited the cinema. Now we know that a box of 4, every little box accounts to 10, or a box of 4 equals 40. So looking at children, we've got 40 plus 40 plus 40 plus 40, and 40 times 4 is going to give me 160. Then says how many more students than adults visited the cinema. So again, if I just total up the students, that's 40 plus 40, 40, 40, 40 and 40. So that's 40 times 6, which is 240. And if we do the adults, that's going to be 40, 40, 40 and 20, which is going to give me 140. So then all I need to do is take away those two numbers. So I've got 240, take away 140, which equals 100. Moving on to question 3, it says a bar chart is shown to show the number of people visiting a cinema 1 month, and we've got adults, children and students. And it says give one criticism of the bar chart. So again, when criticizing a bar chart, you always want to look for equal spaces. You want to make sure the bars are equal length, and you also want to make sure that there is a gap between each of the bars, but also look at the scale going upwards as well. Now, as you can see, initially the scale, vertical scale, goes up in 500s, but here we can see we've got an error. So here we can say something along the lines of that the scale on the vertical axis is not consistent, and it should, we can write in brackets, or if you want to go into a little bit of detail, should go up in 500s, which from 2000 to 3000 it doesn't, because it goes up by 1000. Moving on to question 4, it says that in an election there were 4 candidates, J, K, L and M. Fran is drawing a pie chart to show the results. The sectors for J and K have been drawn. Twice as many people voted for L as voted for M. Complete the pie chart. So for this, what we need to do is basically split this up. So if we say that M is X, then L is going to be 2X because there's twice as many. So we know that angles around a circle add up to 360. So what I've then got is if I then just draw, I don't know, a fictitious line here, then this is going to be X and that is going to be 2X. So in working out what X is, we know that 2X plus X plus 72 plus 90 equals 360. Now if I simplify that, get 3X equals plus 162 equals 360. Take the 162 over to the other side, so 162 take away from 360 is 198. So then X equals 66. So here we know that M is going to equal 66 degrees, and L, which is going to be 2 lots of that, is going to be 132 degrees. So all that's left for me to then do is plot that. So if I just get rid of this, now again it's very difficult for me to do this accurately on the screen, but I would say something along the lines of, let's just make sure that that is in the center. So I would go as far as saying that your line should look something like this, where M is the smaller one and L is the bigger one. And again, if you want to mark what they should be, so that should be 132 and that should be 66. It should look something like that. Moving on to 4b, it says altogether 16,200 people voted. How many people voted for J? So for this, what we need to do is first of all work out the proportion of the pie chart that is J. So the portion is 72 over a total of 360 degrees, and we multiply that by the grand total, which is 16,200. So again, if we type that all into my calculator, I get the correct answer of 3,240. Now moving on to question 5, it says a music festival has taken place each year from 2011. The table shows the number of people who attended each year. The festival organisers drew a time series graph to represent the data. The first 4 years have been plotted, and for part 8 it says complete the graph. So all we need to do here is basically add the next couple of years after the 4th one. So let's just go back to the question. Here we go. And you want to make sure that you can see the table. So the first 4 have been done. Don't know why I'm crossing them off, because I shouldn't be doing that. Let's get the highlighter. So those 4 are done. So the next one for me to plot is 2015, which is at 2023. Now again, you want to just try and get as close as possible. So for this, that's going to be there. For 2016, that's going to be 26, so that's going to be there. For 2017, that's 32, which is about there. And for 2018, it is at 37, which is about there. So all that's left for me to then do is, with a straight line or with a ruler, is just simply join those points up. Now again, not doing very good practice because these should be straight lines. We should end up with something that looks like this. And again, remember, do use a ruler. For 5b, it says use a graph to estimate the number of people who will attend the festival in 2019. So as you can see that it is going to be increasing. So if we just write 2019 here. Now in terms of acceptable answers they would accept any answers between 4,200, which is there, and 4,500, which is here. So any answer between this range here, between 4,200 to 4,500, will be acceptable for that mark. And as it's worth 2 marks, I would strongly recommend that you draw a dot and then draw a line and then read off the value. Moving on to question 6, it says that a company pays people to visit shops and test customer service. Paul works for this company. His fees in October are shown. And it says calculate the mean fee. So let's just zoom in so we can actually see this on the screen. So for this, we want to work out mean from a frequency table. So the first thing we need to do is basically add all of these numbers up in the frequency column, which comes up to a total of 40. Then I need to create an FX column, in which all I need to then do is just multiply the first column by the number in the second column. So this is going to give me 80, that's going to give me 180, that's going to give me 72, that's going to give me 60, and that's going to give me 20. And if I add all those numbers up, I get 424. Then to work out the mean, it's basically the total of fx, which is 424, divided by the total frequency, which is 40. And if I type that all into my calculator, get an answer of 10.6. Well, because it's dealing with money, I want to add a 0, so the answer then is £10 and 60 pence. It then says Paul says that the modal fee and the median fee is both £10. Is he correct? Well, here the modal group is the one that's the most popular. As you can see, that is £10. So the modal group equals £10. Now, if there's 40 people, then the median is going to be the 20th person. So we're looking at where the 20th person will be. So if we line them up all from the cheapest to the most expensive, where would the 20th sort of fee be? And it'll be in the 10th. So here we could say that the median equals the 20th job, which equals £10. So he is correct. Moving on to question 6c, it says Shelley also works for his company, for this company. Her fees in the same month are shown, and it says give one similarity and one difference in the fees of Paul and Shelley. So again, a couple of answers you could give here. So for similarity, we could say that they've got the same range. So go from 8 to 20. We could say that they've got the same mode, as both peak at 10. We can also say that they've got the same frequency for £15. So something along those lines would be absolutely fine. For the differences, we can say that they're going to have different means, if you've worked that out. You could also say that they've got a different median. And we can also say that Shelley visits 50 times, whereas Paul visits 40 times. So something along those lines. Any one of those comments for each of those categories will be absolutely fine. Moving on to question 7, it says here are some numbers, and it says circle the range. Now remember that the range is the biggest number, take away the smallest. So it's going to be 7, 17, take away 5, which is 12. It then says for question 8, 11 people play a game. Here are their scores. And it says write down the mode. So the mode is the one that appears the most, which in this case is 9. The next one then says work out the median. So the first thing we need to do is we've got 11 numbers, so let's just put 11 little dashes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we then need to order these numbers. So the smallest is 3. Then we've got 3 9s. And let me just tick them off as I'm doing them so I'm not forgetting. Then the next smallest is 12. Then it's 14. Then it's 15. Then it's 16. Then it's 2 18s and a 20. Now the median is the middle number. So again, one from the bottom, one from the top until we get to the middle, which in this case is 14. Now it's really important you do show that you've ordered the numbers. As this question is worth 2 marks, you would get a mark for an attempt at ordering those numbers. So make sure you do show that, even if you can spot it straight away. So question 9 says Mark went fishing on 4 Saturdays. And it says for 9A, work out the mean number of fish caught per hour in week 1. Well, in week 1, he caught 4 fishes over 2.5 hours. So it's going to be 4 divided by 2.5, because again, it's the fish per time, which is what they're wanting. So it's going to be fish per means divide by the time. So if we do 4 divided by 2.5, we get an answer of 1.6. Then for 9B, it says Mark says one of the fish caught weighed 5 kilograms. In what week did this happen? So for this, what we need to do is work out the total weight for collected in each week. So the total weight in each week. Now for this, all we need to do is basically just multiply the number of fish by the mean weighting. So for week 1, it's going to be 4 times 1.2, which is 4.8 kilograms. For week 2, so let me just write week. For week 2, it's going to be 1 times 2.3, which is 2.3 kilograms. For week 3, it's going to be 6 times 0.8, which is 4.8 kilograms. And for week 4, it's going to be 3 times 1.9, which is 5.7 kilograms. So the only week where he could have caught a 5 kilogram fish was going to be week 4. Then moving on to question 10, it says the scatter graph shows the length and width of 20 birds' eggs. One of the eggs has a length of 52 millimeters. What is its width? Now for this one, it's going to be basically this one here. We'll just mark that as part A. So then we're looking for the width, which is 40. Then for 10B, it says all of the points except one show strong correlation. Circle the point that does not fit the pattern. Well, for strong correlation, we want to draw a line of best fit. So if we imagine a line of best fit looking something like this, which one stands out? Well, it's going to be this one here. So if you have circle for part A, make sure you get rid of that, because on the scattergram we only want to show one of those points circled, which is that one there. Then moving on to 10C, it says match each scatter graph with the description. The first one has been done for you, so if I just zoom out a little bit, we can see, of course, it's going to reset. So there we go. So here, the second graph shows extremely strong positive correlation because the line's going upwards and it is virtually in a straight line. So that's going to be connected to the first one. And the third graph shows absolutely no correlation. So that's going to be that one there. Then moving on to question 11, it says the scatter graph shows the best high jump and best long jump for 15 boys. And it says write down the type of correlation that is shown. So for this, only worth 1 mark. So we only need to say whether it's positive or negative. And this one is positive. It then says Liam has a high jump of 166 centimeters. Use the line of best fit to estimate the best long jump. Now, for this to be done correctly, your line of best fit needs to fall within a certain category. Now, that certain category needs to be at between 150 and 504. So that's going to be roughly about there. And a peak at 512. so that's going to be there, and the upper is going to be at 180 and 550, which is there, and 558, which is there. Now, so in terms of what I've just done is I've just done the boundary as to where your line of best fit needs to go. So your line of best fit needs to fit between the two lines that I'm drawing now. Now remember that your line of best fit does not have to go through the origin, so in other words, doesn't have to start at 0, 0, and in this case it shouldn't anyway. So as long as your line of best fit falls within the two lines that I've drawn here, you're absolutely going to be fine. So let me just draw my line of best fit, and I would say that my line of best fit, let's use blue, is going to be somewhere, I would say roughly around there, right in the middle. So then it then says use line of best fit for the best high jump of 166, or 166 is here. So as soon as it hits my line of best fit, I then want to project across. So again, as long as you're using your correct line of best fit, that should be absolutely fine. And I get mine to be roughly around about 532, give or take. But I would say any answer between 526 to, I would say, 538 would be acceptable answers. Then moving on to our last part, it then says another boy has a high jump of 195. Give a reason why you should not use line of best fit to estimate the best long jump. And again, the reason for this is because it is outside the range of values, because the line of best fit only works between the lowest result and the highest result. So anywhere between, I would say, 147 and 158 would be acceptable to use a line of best fit. Anything outside that range is not going to be appropriate for this. And a more mathematical word is extrapolation. And there we go.